So, the name of the chapter is the Earth. First of all, we will be dealing with the early theories regarding what? Regarding the origin of the Earth. A large number of hypotheses were put forward by different philosophers and scientists regarding the origin of the Earth. One of the earlier and popular arguments was by German philosopher Immanuel Kant. Mathematician Laplace revised it in 1796. It is known as the nebular hypothesis. The hypothesis considered that the planets were formed out of a cloud made up of material associated with the youthful sun, which was slowly rotating. So if we go by the chapter, what is written in the book, so it is very hard to explain and even to understand. So let me put all these concepts in some simpler terms. Origin of the Earth. We know that there are two types of theories behind the origin of the Earth. The modern theory and the early theories. Early theories include like gaseous theory, nebular hypothesis, planetesimal theory, and the revised nebular hypothesis. We know that our universe, it comprises of countless galaxies, and each galaxy contains numerous stars, and around some of those stars, the planets revolve, just like our 8 planets revolve around a star called the sun. The gaseous theory by Immanuel Kant. Immanuel Kant, he assumed that there is a cloud which is made up of gases and dust, and it is cold in nature. There is a cold spinning cloud of gas and dust, and it is rotating or spinning constantly. And this cloud is known as the nebula. So what is a nebula? Nebula is a giant cloud of gases and dust in the space. And from where did this nebula resulted? So after the Big Bang took event, nebula, it resulted from uneven distribution of gases throughout the universe. Now the first step, we will study about the creation of the solar nebula. See what happened. This is the nebula, and in the center of the nebula there is lots and lots of gravitational pull, which cause the matter to be pulled towards the center of the nebula, or the matter, it condensed to the center of the nebula, due to which what happened, the rotation of as the size reduced, the rotational speed of the nebula, it increased, and this caused the clouds to flatten, and they flatten to form a disc-like structure, which is known as an accretion disk. Then what happened? See, we know that in the center of the nebula there was a lot of gravity, and the matter, it continued to collect in the center of the nebula, as you can see in the picture. And what happened? See, there was a lot of matter collected in the center of the nebula. More mass, more pressure, and more pressure, it led to a rise in temperature, a further rise in the temperature. Then what happened? There was a further increase in the mass in the center of the nebula, which ultimately led to increase in gravity, increase in pressure, and ultimately increase in the temperature. Due to which a ball of hot gases was created in the center of the accretion disk, which is known as this ball is known as the protosun, which later on developed into our sun. And what about the planets? See, at the periphery of the nebula, there was some matter. You can see on the screen there was some matter at the periphery of the nebula, and these were clumps of like gases, dust, rock, and they accreted or collected to form the protoplanets, which later on developed into planets. Nebular hypothesis. It was put forward by Pierre Laplace in 1796. See, Ne- Pierre Laplace, he assumed that the nebula, the primary nebula, it is hot in nature. It is also made up of dust and gases. It is also spinning on its axis, and also it is hot in nature. Versus what we have studied in the gaseous theory of Immanuel Kant, that the nebula initially it was cold in nature. So, what happened in the nebular hypothesis of Pierre Laplace? He said that the nebula is hot in nature and it is spinning. But gradually, what happened later on, the nebula it cooled down. Due to the cooling of the nebula, the size of the nebula it also reduced or shrank. And we know that smaller the object, more is the rotational speed. Then what happened? This high rotational speed, it led to the ejection of its layer. And this layer which was ejected from the parent nebula, it further shrank due to cooling. It further shrank, and there was even more or a further rise in the rotational speed of this ring. And this led to the formation of the planets. Let us see how. See, on these rings there were some particles of gases and dust which later on grew in size due to agglomeration. Later on, this agglomeration or some a clump of gases and dust, it later on cooled and they got condensed into planets. 1800, Chamberlain and Moulton considered that a wandering star approached the sun. As a result, a cigar-shaped extension of material was separated from the solar surface. As the passing star moved away, the material separated from the solar surface continued to revolve around the sun, and it slowly condensed into planets. This is the planetesimal theory or the planetesimal hypothesis by Chamberlain and Moulton. What they told that there are, first of all, there are two stars. All right, first is the our youthful sun, and the second one is the wandering star. Now the sun, the youthful sun, it is smaller in size than the wandering star, as you can see on the screen. What happened? Due to the gravitational pull, you can see the wandering star, it is larger than our youthful sun. So more mass, more gravity. So what happened? Due to the gravitational pull of the wandering star, a cigar shaped, you can see on the picture on the screen, that a cigar shaped material, it got extended from what? Our youthful sun. And later on, this cigar shaped extension, it orbited the sun. You can see on the screen, it started to orbit the sun. So if I ask you what are planetesimals, the cigar shaped extension was separated from the solar surface and called planetesimals, have small sizes. See, we have already seen the cigar shaped material which got extended or got separated from the youthful sun, and they are very small, smaller in size, and they are known as the planetesimal. Later on, these many planetesimals, they came together or they combined to form a larger body, which were later on known as the planets. Sir James Jeans and later Sir Harold Jeffrey supported this argument. So the theory of Chamberlain and Moulton was later on supported by Sir James Jeans and Sir Harold Jeffrey. Later on, at a later date, the arguments considered of a companion to the sun to have been coexisting. These arguments are called the binary theory. So we have already seen in the Chamberlain theory that the sun, it was accompanied by another heavenly body. And these types of arguments were known as the binary theories. 1950, Otto Schemme in Russia and Karl Weizsäcker in Germany somewhat revised the nebular hypothesis, though differing in details. So we have seen that the nebular hypothesis was already presented earlier, but in 1950, they presented a revised nebular hypothesis with a different detail. They considered that the sun was surrounded by a solar nebula containing mostly the hydrogen and helium, along with what may be termed as dust. The friction and the collision of the particles led to the formation of a disk-shaped cloud, and planets were formed through the process of accretion. Let's begin. Otto Schmidt in Russia and Carl Bazasker, they revised the nebular hypothesis. And what was that? See, they said that there is a proto-sun, or the sun in its early form. All right, and the sun was surrounded by a gas cloud, and the composition of the gas cloud was mostly made up of gases like hydrogen, helium, and very minute particles or very tiny particles which they called as dust. Initial condition, there was a cloud which was mostly made up of gases like hydrogen, helium, and some dust particles. We know that the object which has more mass, it has more gravity also, as compared to an object which has less mass, means it has less gravity as well. So what happened in the gas cloud? In the gas cloud, there were particles which had more mass as compared to the other particles. So the particles with more mass, they attracted the particles of lesser mass, as you can see in the picture, due to which the gravitational force, it increased. Also, there was a rise in the friction and collision between the particles. These forces, it led to an increase in the rotational speed, and this increase in the rotational speed, it caused the clouds to flatten and create a disc-shaped cloud. So we have already seen that in the cloud there were particles which had more mass as compared to the other particles. The particles which had more mass, they attracted the particles of lesser mass, and this process, it continued, and this is how the planets were formed, and this process is known as the process of accretion.